Grassroots to galaxies. Hey folks, back with another video which was pretty fun creating it. Hope you guys learned something today. Bioluminescence is the production and emission of light by a living organism. It's a form of chemiluminescence. It takes place because of chemical reactions inside the body of an organism. The protein responsible for bioluminescence is called photoprotein, for example, E. corin. The chemical responsible for bioluminescence is called luciferin and enzyme luciferase. Now coming to photoelectric effect, it is the emission of electrons when electromagnetic radiation such as light hits a material. Electrons emitted in this manner are called photoelectrons. Best example for photoelectric effect is the working of a solar panel. The alkali metal cesium shows the most photoelectric effect. Photoelectric effect occurs in metals which has low ionization energy. Bioluminescence occurs in all kingdoms of organisms for a wide variety of reasons, including communication, camouflage, to lure prey, and many more. Bioluminescence can be seen in many colors across 5 kingdoms like green, red, blue, and many more. Photoelectric effect depends on the intensity of the light beam. The higher the intensity, the higher the electric current. Minimum wavelength for photoelectric effect is 683 nanometers. So from the title of the video, we question that is it possible to generate photoelectrons with bioluminescence? Let's discuss the issues behind it. Our big issue is that bioluminescence does not take place for a substantial amount of time. So, if photoelectric effect is possible due to bioluminescence, it won't be for long. To address this, we need to increase the life of the luminescence. We think that biotechnology can address the issue. Next comes the wavelength needed for photoelectric effect, which is around 700 nanometers. But if we go to the bioluminescence spectrum, we can see that the maximum wavelength is barely 600 nanometers. Which means sadly we cannot conduct this experiment in the immediate future. But with few tricks of biotechnology, we can mess with the chemical responsible for bioluminescence and change the DNA of the organism to synthesize stronger chemicals and hence achieve required wavelength. Next comes the material responsible for photoelectric effect. With accelerated research, we can invent a material which can show photoelectric effect even at lower wavelengths. Now coming to the uses of this setup, to be honest, we don't have any applications. But just imagine that you have a desk lamp and that has a special compartment to house a capsule of this genetically modified organism that shows bioluminescence, and compartment's walls are lined with very efficient photoelectric cells, and just like that you have a lamp for late night work. Whenever the lamp starts to die out, just change the capsule and continue with your work. You guys can add us on Instagram for early updates on videos. If we committed any mistake in the content, feel free to correct us in the comment section down below. This is your Science Sapien signing off.